We have been learning how, when we apply descriptive statistics, we learn a good deal of information from the data. The first step is to visualize the data. It's like when you grab a book and you just flip through the pages to get a sense of what the book is about. That's what we get from visualization. You can use Tableau, you can use Excel, do a histogram, a scatter plot, depends on the data. But the idea is to visualize it. Then we would move into descriptive statistics. We would find out the mean, the median, the mode, perhaps the range, the standard deviation, percentiles, quartiles, identify outliers, and do a correlation. We're going to find out how, just using very basic descriptive statistic concepts, can help us make better decisions. In this example, we have a data set of 36 months. And during the months, this hospital recorded the number of infections that happened after surgery. We're going to assume that the number of surgeries was stable throughout the 36 months. So you can see that the number of infections seem to move from 1 to 3, except for month 12, in which we have 6 infections. Let's take a look at the details. So we'll assume that the number of surgeries performed each month was the same. The number of infections tripled in months 2 and 3 compared to the first month. I'm going to stop there. So let's assume that we only have the data for months 1 to 3, and you are the manager. If somebody sees this chart only from months 1 to 3, they might come up to you and say, your team is really messing things up. The number of infections tripled in month 2 and 3. Well, clearly, from a statistical perspective, only 3 points of data are not enough to understand if there is a trend going on. We would need more data. We would need the 36 months. So even though the number of infections tripled from 2 and 3, we still don't have enough data. We would have to carry on a descriptive statistic analysis, identifying the mean, the standard deviation, and we're going to apply the rules of thumb. So the number of infections fluctuate between 0 and 3, with the exception of month 12. However, the visual analysis is not enough. We need to calculate certain things. We start with the average, the mean, from the number of infections, which is 1.58. And then we also calculate the standard deviation, which is 1.18. We're going to apply the rules of thumb. Remember that the rules of thumb say that 68% of the data will fall to the left of the mean minus 1 standard deviation and the mean plus 1 standard deviation. That 95% of the data would fall between 2 standard deviations to the left of the mean and 2 standard deviations to the right of the mean. And that 98% of the observations will fall between 3 standard deviations. In this case, we know that the standard deviation 3 times and applied to applying the rule of thumb gives us between 0 and 5. That is that 98% of the observations should fall between 0 and 5. We have to identify outliers. There's no standard definition of what constitutes an outlier. An outlier could be because somebody made a mistake in the data registration. We should not discard outliers just because. We have to identify what caused the outlier. If it's an error in the data, then we would correct it. If it's not, then unless the research questions allow us to remove that outlier, we should not. Most of the time, we should not. But what is an outlier? Well, Typical rules of thumb include the standard deviation. If a value falls past 3 standards deviation to the right or past 3 standards deviation to the left, we might have an outlier. Another way of calculating an extreme outlier would be using the interquartile range, also multiplied 3 times. So any value to the left of Q1 or to the right of Q3. And a mild outlier, if it's what suits you, would be 1.5 multiplied by IQR. In this case, when we apply the empirical rule, what we obtain is that any value above 5 would mean that there is an outlier, that there is something off going on here. So based on this, we see from the green line that anything beyond this point should make us stop and look further. Anything in between the lines from the red line and the green, it's within the norm. So from a statistical perspective, we can expect almost all the observations to fall within these limits. So the number of infections of month 12 indicates that we should investigate to know what happened in that month. But going back to the claim of your peer, saying that during the first 3 months, you were doing something wrong because the infections tripled, that claim doesn't seem to have a statistical weight, because we now know that unless we have more than 5 infections per month, everything between 0 and 5 seems to be normal. This is just a brief example on how to apply descriptive statistics in our business decision.